Hello everyone and welcome to my conference workshop and also my home workshop. In today's talk I'm going to cover the architecture and step-by-step implementation for decoding, visualizing, and alerting to really create a starting point for your own LoRa-based end-to-end IoT product. Before we dive in too deep, I want to tell you a little bit more about myself. I've been a software engineer my whole career, started in chemical detection, then went to telecommunications, cloud services, and now of course Internet of Things. The little dice next to my picture means I really like board games and card games. Back when we used to do conferences in person, I would always bring a couple of decks of Magic cards, hoping to find somebody that was going to sit down and play some Magic and talk IoT. I'm the co-founder and the chief product officer for an application enablement platform called Losant. We provide the edge and cloud software foundation on which our customers develop and bring to market their own IoT products and services. The logos on the right are a subset of our customers, really illustrating some of the markets that we operate in. These include industrial equipment manufacturers, smart environment for things like corporate campuses or airports, and then telecommunications. Let's talk a little bit about what we're building in today's workshop. Many of the IoT use cases we hear about are internally facing. They are organizations adopting IoT for their own purposes. That could be reducing cost or improving efficiency. But one of the biggest opportunities in IoT is not just reducing costs, but also generating new revenue through selling an IoT product or a service. So what we're going to build today is the start of a turnkey voltage monitoring product that an organization could sell to their customers. One of the main reasons we see organizations adopt this strategy is to transition from a one-time revenue model to a recurring revenue model. Think about an industrial equipment manufacturer. Once I buy that equipment, for the most part, the transaction is complete. But if that manufacturer can also sell an IoT product, something like remote monitoring, that extends the value of that equipment, that can be offered as a subscription service. And the reason I wanted to talk about what we're building is the differences between an internally facing application and an externally facing application change the way we think about the architecture and the implementation. In many ways, an internally facing application is easier to build. It's a single tenant application. The only people viewing the dashboards or receiving alerts are members of that one organization. As soon as you flip that around, now the equipment that you're monitoring is owned by the customer. The customers are viewing the dashboards, the customers are receiving alerts. You're switching from a single tenant application to a multi-tenant application. All that said, now let's take a look at the architecture behind the application we're going to build. Data originates from the radio bridge voltage sensor, goes through a gateway, ends up in the Things network. I'm not going to cover that part in this workshop. What I'm going to cover is receiving data from the Things network over an HTTP integration, and then within Losant, we're going to decode that information, we're going to visualize that information, and then we're going to build that multi-tenant alerting so that our customers can receive SMS notifications. So let's return back to my home workshop where we can see this application working end to end. So just like the architecture diagram, my lab setup starts with the radio bridge sensor. Its voltage source is this small solar panel, which will generate 0 to roughly 4 volts. It's sending data to the Things gateway, which is reporting that up to the Things network. The HTTP integration is then forwarding that data to Losant platform, where we've got some visualizations. For the last few days, this solar panel has been in my window, so during the day the voltage is high and at night the voltage gets pretty low. But here on the lab table the voltage is about 2 volts. We're also showing some information about the device itself, including the battery level and also a history of tamper. So this sensor and a lot of sensors on the market have built-in tamper switches, and we can test that out by essentially removing the lid. So the built-in tamper switch is on a little spring, and if you take the lid off, that will cause the tamper button to depress, which will immediately result in the device sending a notification, which will show up on the mobile phone. Okay, it's time to start building our application. What I have here is a Losant application created from our Things Network application template. Most of what I'm going to show today can be created for you automatically if you choose to use that template as a starting point for your own applications. The first thing we have to do is get data from the Things network or any network server into the Losant platform. And one of the most popular ways to do that is through webhooks. In Losant, when you create a webhook, it will create a new unique URL that then you can give to your network server as a way to send data into Losant. I'm not going to cover a lot of details here, but the one thing I do want to touch on is security. You want to make sure the information that you receive is coming from a trusted source. So the Things Network allows you to create an authorization header that it will send along with the data that it posts to your webhook. Let's come back to Losant and talk about what happens after the network server posts data to your webhook. In Losant, all of an application's logic is done through our drag and drop workflow engine. So in this case, whenever information is received by the webhook, it's going to trigger this workflow, and you can add as many nodes as are necessary to handle that specific request. On the debug output on the right, you can see all the information sent to us from the Things Network, including the payload and all the headers. And as I mentioned before, the very first thing we need to do is make sure the value of that authorization header is correct. We want to make sure what we receive came from a trusted source. If it's not, we're going to go ahead and ignore this request. Now, before we get too far, I want to look specifically at the payload that we got from the Things Network. If you've ever worked with LoRa devices before, you might know that decoding your sensor information is one of the first challenges you'll run into. And somewhere in this string exists some voltage information coming from our sensor. So I'm going to spend a couple of minutes really diving deep into the technical details of how to decode information that looks like this. Well, this is certainly the most technical I'm going to get in this workshop, but since decoding information is likely the first hurdle everyone hits when using these types of sensors, I thought it was worth a couple of minutes to take a deep dive into this concept. On the left, I've got the documentation for my specific radio bridge device, and on the right, we've got the steps as we slowly decode this information. It all starts from the Things Network. They're going to take that raw sensor information and encode it as a base 64 string and post that to our webhook. The first thing I need to know is what type of message I received. So if I go back to radio bridge documentation, I can see the message type is stored on the second byte. So if I look at the second byte after decoding that base 64 string into individual bytes, I see it is 14. And 14, according to radio bridge's documentation, corresponds to a voltage measurement event. Now I can look at this table and understand what the rest of that payload represents. The next byte represents the specific type of voltage measurement, and then the following 2 bytes are the actual voltage measurement itself. So looking at that next byte after 14, I see it is 00. So going down to the third table, I can see 00 is a voltage measurement type of periodic report. My sensor is configured to report voltage information every 5 minutes, so I'm going to get one of these periodic report events every 5 minutes. Then the last 2 bytes, 000D, those are the actual voltage. And according to their documentation, that is in a range of 0 to 3000 and in units of 10 millivolts. What that means is that it is an unsigned integer that is 2 bytes long, or in other words, an unsigned short. So we can take the 000D, decode that into an unsigned short, and we get 13. Finally, we need to divide that by 100 to convert it from units of 10 millivolts into units of voltage. And we get a final reading of 0.13 volts. Coming back into Losant, now we need to implement that decoding logic so we can convert that raw information into telemetry data that we can actually store on our devices. If you're using radio bridge devices, we do have a node that will do that decoding for you. But let's take a look at a function that implements the same decoding logic that we just showed. Losant's function node is JavaScript and Node.js, but the same concepts apply to pretty much any language. Inside Node.js, they have a buffer object, which is perfect for working with binary data and arrays of bytes. Now, normally we would construct it from the actual data we got from the Things Network, but for this example, I wanted to use the exact same payload we were just showing. So I'm going to construct a buffer from that base 64 string, and I'm going to tell it that that data is encoded in base 64. That lets the buffer know how they're supposed to decode that information. That's going to result in that array of bytes identical to what we just showed. From then I can start doing those same checks. I can look at the second byte and see if it's 1-4, which meant it was a voltage measurement event. And then the subsequent byte, if it is 0, we know it is a periodic voltage measurement. So then we can read the actual voltage out using a function on the buffer object called read unsigned int, 16 bits. A short is 16 bits in length, and we're going to start from index 3. So if we're looking up here, we can see 0, 1, 2, 3. It's going to read 16 bits or 2 bytes and convert that to an unsigned integer for us. We then divide that by 100 to get our final measurement. So if I return to the workflow and execute that function using a virtual button, we can see here in the debug output, I've got my final voltage as 0.13. Well, since I am using a radio bridge sensor, I can use our radio bridge node to handle that decoding for me. Behind the scenes though, it is using a function node very similar to what we just showed. I'm looking for 3 different types of events. Supervisory, which includes some information about the sensor itself, including its battery level, the voltage measurement, and also tamper. So if someone does take that lid off, I'll get that tamper event. After you've decoded the information, the next thing you have to do is store it. Store it in some time series database. And inside Losant, that's called device state. So now we can take that decoded information and store it on what we call an attribute on a device model. A question you might have is, how do we know which device to store this on? Our application could have hundreds or thousands of devices. Well, we do get the actual ID of the device from the Things network. It's sent to us through the payload as a property named dev_ID. So if I switch to a Losant device very quickly, we'll see I have tagged all of our devices with that same key and their unique identifier. That allows us to look up a Losant version of this device based on that LoRa ID that we get through the Things network. And then right above that decoding, I'm actually getting the Losant device based on that ID. If it doesn't exist, we just ignore the request, but this is a good opportunity to implement something like on-demand device registration. So if you do receive information for a device you don't know about yet, you could just create it on the fly and then continue this workflow as if the device already existed. So at this point, the decoding step is complete. We are receiving information from the Things network. We're authorizing the request. We're getting the Losant version of that device based on that external ID. We're decoding the information, and then we're recording that information into a time series database on that device itself. So if we switch to a device, we can see some information coming through. We've got voltage, we've got battery voltage from that supervisory message, another voltage. So at this point, we can kind of shift to the visualization step of this workshop. We have the data now. Now we can put it on a dashboard. The dashboards in Losant are primarily designed to show attribute data stored on a device. So I want to spend a couple of minutes describing what attributes are before we switch over and look at the dashboard. Attributes contain the ever-changing telemetry data for your Losant devices. So in this case, my radio bridge devices have the actual voltage measurement, the voltage of the internal battery, and an attribute to record if it's ever been tampered with. So each time information is reported to this device, in this case, as I can see on the right-hand side in the debug output, that voltage measurement is being recorded onto the voltage attribute, which is then stored in Losant's time series database. Once data is on an attribute, it can be easily displayed using our dashboarding tools. Okay, switching to a dashboard, we finally got to something that's in the actual title of my workshop, which is visualization. But there was a lot of stuff we had to do before we got here. We had to decode all that information and then also store it before we can put it on one of our dashboards. So you saw this dashboard briefly earlier when I took you through my lab setup, but let's go through it in a little more detail. The time series database here is showing 3 days worth of voltage information. Like I said, that solar panel used to be in a window, so the voltage was high during the day and would drop pretty low at night. Except for today, where it's been sitting on my lab table under a fairly constant light, giving it a fairly constant voltage. The gauges on the right here show the current voltage, as well as the maximum voltage over that 3-day window and the minimum voltage over that 3-day window. Scrolling down, we can see some information about the device itself, including some historical information about the battery voltage, as well as the current battery voltage in a gauge. And then we also have a history of all of the times the tamper switch has been triggered and a indicator block showing the real-time value of the tamper switch. So scrolling back up, let's take a look at how some of these dashboard blocks are configured. We'll start with this time series block. Dashboarding in Losant is pretty easy, and if you've used any dashboarding tool, a lot of this will be familiar. We've got the option to do a live stream or historical. Live stream's kind of cool if you're collecting data at a much higher frequency, maybe once every couple of seconds. But in this case, I want to show 3 days of information, so I'm going to choose historical. The duration here is 3 days, and the resolution, which indicates how often I'm going to get a data point, I set to 20 minutes. So each data point on my resulting time series graph will be 20 minutes apart. After that, we can add any number of segments to this graph that we'd like. In this case, I only have one, which is the voltage. We can choose one or multiple devices, so I could choose the specific device I want. Our dashboards also do support context. So if you did have thousands or millions of devices, you don't want to make 1 million dashboards for 1 million devices. You want to create one dashboard and be able to pass in the device you'd like to display. And we call that context. So what I'm choosing here is a context, which allows me to switch between a few of my devices that I have in this application. The attribute that we want to graph is voltage. So like I mentioned earlier, all of that telemetry data we're decoding and storing is being put on device attributes. And this is one of the primary purposes and places to use those attributes. The aggregation works with resolution. So I have a sensor configured that reports every 5 minutes, but I'm only shown a data point every 20 minutes. So every data point on my graph is made up of 4 underlying sensor readings. So the aggregation controls what am I supposed to do with those 4 data points. The most common is to average them together, but in some cases you want to make the minimum one or the maximum one or any other of a bunch of aggregations that we provide. All of the rest of the options here are mostly visual, so you can just change the color and look and feel of the graph, and I don't need to go into those. So let's return to the dashboard and take a look at a different block. Let's take a look at this gauge block showing the maximum voltage over 72 hours. This does a good job showing a different type of aggregation versus an average. So we can go in here, and again, we're going to look at historical data, 3 days. There's no resolution on this because a gauge only shows one data point. So no matter what, you're going to aggregate all 3 days worth of data into one value that's going to be presented to the user. Again, I'm choosing my context device, but if I wanted, I could just pick an explicit device. Very common for early development. And again, I'm going to choose my voltage attribute. So in this case, the aggregation is a maximum instead of an average. So what I'm saying is over that 3-day window, return me the maximum voltage that was received. I want to display that as a number. We do have other visuals. I showed a battery a little bit earlier, but I just want the number, set the label to volts, and the rest is just presentation. Okay, let's return back to the dashboard and take a look at a couple more dashboard blocks. Let's look at the Tamper History, which is a device state table. It allows us to display all of the attribute data that has been reported for a specific device. Coming in here, things are going to look pretty familiar at the top. Again, setting duration to 30 days, choosing my device, but the configuration changes when we get down here to the column configuration. This is where I choose which columns I want to display in this table. First, I've got the timestamp, which records when this attribute was reported, and then I'm adding a column for the tamper attribute itself. The state table does support different types of columns depending on what you want to display. But let's expand that tamper column and look at a specifically powerful feature that we have when it comes to templating. So tamper behind the scenes is reported as a 0 or a 1, and it's kind of reversed from what you might think. 0 means it's been tampered with, and 1 means it's not tampered. And that's because the button is constantly pushed down. It's basically constantly a digital 1 being reported into the device, and as soon as the lid is lifted and the tamper button is depressed, that digital input turns from a 1 to a 0. So the templating here allows us to change what's displayed to be a little bit more user-friendly, and especially important when the underlying data may not be that intuitive. So our templating in Losant is done with Handlebars. Handlebars is an open source, fairly popular templating engine, and you'll see templating in a lot of different places. We saw it in the workflow engine. You'll see it a lot in the dashboarding here, and it's used as the primary templating engine behind our end user experiences. So what I'm checking here is if that value is equal to 0, I'm going to instead display the text switch open. Otherwise, display switch closed. So that gives me a table with much more user-friendly labels compared to the raw underlying data. Okay, coming back to the dashboard, the last block I want to show is the indicator block. So a real-time indicator with a nice color giving me information of whether or not that tamper switch is currently open or closed. So coming in here, once again, I'm going to choose historical, but instead of choosing something like 30 days, I'm going to choose the last received data point. That's because I want to see the live or real-time status of that tamper switch. Our indicator blocks are made up of queries and then conditions. Queries control what data you need, and then conditions control how you want to display that data. So in this case, I just want the tamper attribute. So every time this block updates, I will receive the last received data point for the tamper attribute for this specific device. And then I have a condition that controls how I want to display the value of that tamper attribute. So in this case, as we learned before, the switch is open if the value of that attribute is 0. So here's an expression using a template. If value is 0, change the color of the block to red and change the label to switch open. And then there's also a default condition if none of the other conditions resolve to true. In this case, I'm just saying switch closed and make the color green. So to see what it would look like when that tamper switch is open, I can switch to the simulated device that comes with our Things Network application template. This will also show what it looks like when I'm switching that dashboard context between two devices. Right now that context is set to this voltage sensor, which is all the information I'm seeing here, but I can change that to the simulated device, update this dashboard, and now I'm looking at the same dashboard but a different device. And we can see my simulated device currently has a switch open, which means my indicator has gone to red and my label has changed to switch open. Losant dashboards do include a lot of out-of-the-box visuals that can serve a variety of application types. For our use case today, building that voltage monitoring IoT product, the time series graph, a few gauges, and that indicator block are going to work really well for us. The only other one I really want to point out is the input controls block. Losant is a bidirectional platform, so we can receive information from devices, but we can also send information back to devices. The input controls block allows you to accept user input directly on a dashboard and then send that as a command to a device or trigger a workflow to do any kind of custom logic with that input that you might need to do. Okay, now that we're done with dashboarding, let's return to the architecture diagram and see where we're at in today's workshop. We are successfully receiving information from the Things Network. We are decoding that raw sensor information, turning it into telemetry data that we're storing on devices in Losant's time series database, and we just completed putting that information on dashboards. So the last part of this workshop is going to get into alerting. You know, dashboarding is pretty cool for a couple of weeks, but for the most part, your customers are going to pretty quickly ask, why don't you just send me an alert when something's wrong? And this is where we're going to get into that concept of multi-tenancy. We want to implement sending alerts to the customers that own the specific device. So here we are back in the overview page for the application we've been building. And I want to reiterate everything I've shown today is provided by that Things Network application template. And that's a great place to get started when you're building your own applications. In order to send an alert, the first thing we have to do is actually capture those alerting conditions. And in Losant, the place we have to capture and track those exceptional occurrences are what we call events. And as you can see, this application does already have a number of events created. If we check one out, in this case a tamper detected event, we can see some details about what these include. They've got a status, they do have the device that generated this event, a message, and then the ability to change the state and add a comment. So if someone were to figure out what the problem was and resolved it, they can do that right here. Now, in order to create events, this application template does come with a workflow that automatically creates events under a few different scenarios. So in this case, we're creating events for tamper, voltage, and battery. Let's focus on the tamper event. That's the one I'm going to send those SMS alerts for. Events are created from that incoming telemetry data. So in this case, I am triggering on device state. If you remember from that workflow that decodes the information, one of the last nodes is a device state output node. Whenever device state is recorded to a device, we can trigger a device state trigger in other workflows. This allows us to keep our workflows small, kind of like functions in programming language. You want each workflow to do a relatively small amount of work. It makes ongoing maintenance a lot easier. So in this workflow, we're going to trigger on basically any device, and we're only going to trigger when the tamper attribute is reported. Next thing we're going to do is make sure that tamper state is open. If you remember from earlier, the tamper state is 0 when that switch is open. And then we're going to create that event. And creating an event has a subject, a level, a message, and then we're also going to associate it with the device that reported that information. Now, creating an event doesn't automatically generate an SMS alert. All we're doing is adding an event to the list of events in this application. In order to create an alert, we're going to make a new workflow that is triggered whenever an event occurs in order to send that SMS. So what I have here is a blank workflow. So let's start building this up and see how we might generate an SMS alert when an event is created. I'm going to start from that event trigger. My tamper events are critical with the tamper detected subject. So whenever any event that matches this gets created, I'm going to trigger this workflow. Next up, since I want an SMS alert, I'll put the SMS node on here. And then you can probably see we're kind of stuck. If this were an internal application, I might have the phone number of some error reporting system that I can send, but what I need is the phone number of the customer that owns the device that created this event. So this kind of basic alerting that would work in a lot of internally facing applications doesn't quite work when you have to know which customer you're supposed to send to. So what we have to do is start creating a customer and device association so we can look up the appropriate person to send these alerts to. And in Losant, that device and user association is done in our end user experiences functionality. I'm not going to go into a lot of this. There's a lot of functionality here, but really this controls the customer-facing side of your IoT product. What we need to focus on today is the users and groups. Users and groups allow us to define those tenants, basically your customers, and then each group can have one or more users and then any number of devices associated with them. So in this case, I have created a group for Acme. Acme represents a customer of this voltage monitoring solution. Within Acme, there are two users. One is me and one is a second example. Users have a couple of built-in fields, and then a lot like anything else in Losant, do have tags. And the important tag here is the phone number. So you can probably see how we're starting to bring together that contact information that we're going to be able to use to send an alert to this user. Groups are associated to devices. So in this case, this group has this one voltage sensor. So whenever that sensor triggers a tamper alert, now I know what group to look into and be able to query the list of users in order to send that alert. So let's look at a modified version of the workflow that does implement that lookup from a device to the users that own that device. Just like before, it starts with the tamper trigger. What we're going to do then is get all of the users associated with that device, and then we're going to loop over them. So inside this loop node, the first thing we do is get the full user object. That's going to give us access to that phone number tag that we showed earlier. And then finally, we can send an SMS notice to that correct user. And with that, we do have now our complete end-to-end application. So returning back to the architecture one last time, just to recap what we've built today, we're receiving information from the network server, decoding it, visualizing it, and then we've implemented that multi-tenant alerting so that the correct user gets a notification based on the devices that they own. Well, that's it for my workshop. I'm really glad you were able to spend some time with me today. For next steps, you can find us at losant.com. Everything I've showed you today can be done for free using our developer sandbox and the Things Network application template. Thank you.